Welcome to the future of connectivity. We're standing on the brink of a technological leap that promises to redefine our digital world. This isn't just an upgrade, it's a revolution. Today we're talking about 6G, the sixth generation of wireless technology. It's poised to transform how we live, how we work, and how we interact with everything around us. Building upon the foundational advancements of 5G, 6G aims to push the boundaries of what's possible. Why does this matter right now? Because the foundational research and development happening today will shape the next decade of innovation. Understanding 6G isn't just about future-proofing, it's about anticipating the technologies it will enable. Consider this. While 5G promises peak speeds of around 10 gigabits per second, 6G is projected to reach speeds potentially 100 times faster. That's a staggering leap. The core promises of 6G are truly ambitious. We're looking at unprecedented speeds that dwarf current capabilities. This comes alongside ultra-low latency, reducing delays to near zero. These enhancements unlock a suite of enhanced capabilities we can only dream of today. The vision is clear. 6G is paving the way for a truly interconnected and intelligent future, where the physical and digital worlds merge seamlessly. It's important to remember that 6G is still in its early stages of development. We're talking about research labs and theoretical models, not widespread deployment yet. However, its potential impact is vast, extending far beyond simple improvements in phone signal. It touches every industry, every device, and every interaction. The primary focus of 6G development is squarely on speed and capacity. This is where the most dramatic numbers emerge. Predicted data transfer rates are expected to exceed 1 terabit per second. That's 1,000 gigabits per second. To put that in perspective, this is significantly faster than even the theoretical maximum speeds of 5G. We're moving from gigabits to terabits. This immense speed and capacity mean 6G networks can seamlessly handle massive volumes of data simultaneously. Think about the data generated by billions of connected devices. This capability is essential for enabling truly emerging technologies. The immersive experiences promised by the metaverse require this level of bandwidth. Augmented reality, or AR, will become far more sophisticated and responsive. Imagine complex digital overlays interacting perfectly with your physical environment. Virtual reality, or VR, will achieve unprecedented levels of realism and interactivity. Lag and motion sickness could become relics of the past. To achieve these speeds, 6G will leverage much higher frequency bands than previous generations. This is key to carrying more data. Specifically, research is heavily focused on utilizing the terahertz spectrum. These frequencies offer vast potential bandwidth, but also present unique challenges. Realizing 6G requires significant infrastructure upgrades. This includes developing advanced antenna technologies capable of handling these high frequencies and massive data streams. It also necessitates a complete overhaul and advancement of the core network infrastructure. The backbone needs to support the incredible demands placed upon it. Beyond speed, one of the most defining characteristics of 6G is its focus on ultra-low latency. Latency is the time it takes for data to travel from one point to another and back. The goal for 6G latency is to reduce it to mere microseconds. That's 1,000 times faster than the milliseconds targeted by 5G. The result of this near-zero latency is near-instantaneous communication. Devices and systems will react in real time, without perceptible delay. This is absolutely crucial for a range of real-time applications, where even a slight delay can have significant consequences. Autonomous vehicles are a prime example. Remote surgery, where a surgeon controls robotic instruments from a distance, demands instantaneous feedback. 6G makes this safer and more viable. Industrial automation, particularly in complex manufacturing or logistics, relies on precise real-time control of machinery. 6G can enable entirely new levels of efficiency and flexibility. The underlying need for these applications is paramount: real-time responsiveness. 6G is being designed from the ground up to deliver this. The power of 6G extends far beyond simply improving existing technologies. Its capabilities will facilitate the development of entirely new and transformative applications we haven't even conceived of yet. One major area is the deep integration of artificial intelligence and machine learning directly into the network architecture itself. The network becomes intelligent. This integration enables a range of AI/ML-powered capabilities. The network can intelligently allocate resources based on demand and predicted needs. It can perform predictive maintenance, identifying potential issues before they cause failures. This increases reliability and reduces downtime. Furthermore, it can deliver highly personalized user experiences. The network can adapt dynamically to individual user behavior and preferences. 6G will also provide robust support for the massive expansion of the Internet of Things, IoT. We're talking about connecting billions, even trillions of devices and sensors. This includes everything from smart city infrastructure and environmental sensors to wearable health monitors and connected industrial equipment. The scale is immense. The outcome of this widespread connectivity and intelligence is the creation of a truly ubiquitous network. Connectivity will be everywhere, seamlessly integrated into our environment. Despite the incredible promise, significant challenges are present in the development and deployment of 6G technology. This is bleeding-edge research. One major hurdle relates to the frequency spectrum used. Higher frequencies, like those in the terahertz range, are more susceptible to signal degradation. Signals can be easily blocked by physical objects like walls, buildings, or even rain. This requires new approaches to signal transmission and reception. To overcome these limitations, 6G requires a much denser network infrastructure compared to 5G. More base stations and smaller cells will be needed closer together. This density, combined with the use of new spectrum, necessitates advanced signal processing techniques. Sophisticated algorithms are required to maintain signal integrity and manage interference. There is also a substantial cost factor involved in deploying 6G networks. The infrastructure required is complex and expensive to build out on a large scale. Furthermore, the ongoing maintenance of these highly complex and dense networks will also incur substantial costs. This represents a significant investment for telecommunications companies. Despite the challenges, the potential benefits of 6G are undeniable. The technology promises to unlock new levels of connectivity and intelligence that can reshape society. It holds the promise of enabling groundbreaking advancements in key sectors. Healthcare could see revolutionary changes through remote diagnostics and personalized medicine. Transportation will be transformed by fully autonomous systems and intelligent traffic management. Our cities could become smarter and more efficient. Manufacturing stands to benefit from hyper-connected, automated factories capable of unprecedented precision and flexibility. The industrial landscape will evolve dramatically. Entertainment will become more immersive and interactive than ever before, with photorealistic AR/VR experiences and instant access to massive data streams. Research and development continue globally at a rapid pace. Universities, companies, and governments are all investing heavily in exploring 6G's potential. While a full rollout is still years away, likely in the early 2030s, 6G is already poised to reshape our world in profound ways. It's not just faster internet. It will usher in an era of unprecedented connectivity, where everything is linked and communicating intelligently. Our environment itself could become part of the network, and it will usher in an era of unprecedented intelligence, with AI deeply integrated into the fabric of our digital and physical infrastructure. Hey, if you're enjoying this video and want to see more like it, don't forget to hit subscribe and turn on the notification bell so you never miss an update.